Welcome, viewers. Today we shall have a discussion, online based, titled Data Analysis. First, we start by giving a definition of what data analysis is. Data analysis is the process of converting raw data to meaningful information that can be used for decision making. Remember that we have three types of data according to the definition for today's session. One, data may be quantitative, which means it is in form of numbers. Data may also be qualitative, in form of words. And lastly, data may have both qualities, that is, quantitative and qualitative. Such kind of data, we refer to it as mixed data. The three of them, because of the nature, require different ways of analyzing them. Firstly, let's look at quantitative data analysis. We need to appreciate the fact that quantitative data analysis can be analyzed using quantitative software. There are several quantitative software in the market that can be able to analyze quantitative data. The first one is software with the acronym SPSS. We have Starter, we have MS Excel. You can also use R, Python, MATLAB, and of course, not to forget others like Hamos, among others, M+, quite a number of them. In quantitative data analysis, you may also need to use what is referred to as a hard-in kind of a software that are incorporated in the well-known quantitative analysis softwares. And there are quite a number of pieces of software that you can incorporate as adding in mainstream, if we may use such kind of a word, analysis software. One of the well-known add-in software is AMOS for structured equation modeling and can be applied in SPSS. You can also have what we refer to as a macro for performing a task and can be incorporated in mainstream data analysis software. For instance, we have a macro or a syntax, if you like, for analyzing heteroscedasticity of data. There is a macro by Ahmed 2013 that you can incorporate in SPSS so as to test heteroscedasticity. So what I'm saying is that we have the well-known mainstream software, but then you will need from time to time to add in a software or a piece of code to do a specific task as far as data analysis is concerned. Qualitative data can be also, analyzed using software, and there are specialized software for that. But you also need to note you don't always need to use a software when analyzing qualitative data. Mixed data can be analyzed using quantitative software plus also qualitative ways that may or may not necessitate the use of such kind of software, that is qualitative software. If we can go back to quantitative analysis of data, we need to discuss a few things. First, you have to prepare data by way of coding, which is enabled by the quantitative software. You need to clean the data, check for errors and mistakes, and then you create what is known as a code book. When you open SPSS, you'll find that there are two ways of viewing what you are doing. You have the data view and the variable view. Use the variable view to do coding. So you may as well call it a code book, whereby you define the variables and you also define the data types that you'll use. Additionally, we have the data view. Once you do the coding, you switch into data view, and with that you can be able to put in the data that you'll use in analysis. Analyzing data quantitatively will entail several types of statistics, and some of the terms associated with these statistics should make sense to data analysts. We have what is known as frequentist software, not software but types of analysis, and we have Bayesian types of analysis. Those are two terms analysts of data need to be aware of. We also have confirmatory data analysis and exploratory data analysis. Data analysis can utilize exclusively exploratory statistics, can also utilize exclusively confirmatory statistics. But it is a good idea for an analyst to first explore data before analyzing the data. So what you are saying is that exploration of data is one of the preliminary stages of data analysis, where you look at the distribution, you look at the way the data is, and very importantly, you are able to identify interesting patterns that can be used in hypothesis generation. From there now, you can use confirmatory analysis statistics. It is also very important to understand that statistics can help us to generate hypotheses. They can also help us to test hypotheses. I'm sure in most statistics classes, a picture has been created that, you can only test data. That is, test the hypothesis based on your data that you have collected. But when you look at the work of Turkey, 1977, well, He also did some other subsequent works, but this can be referred to as the seminal work that popularized exploratory data analysis. You'll find that Turkey argues we miss a lot if we don't explore that. There are so many insights we miss if we don't explore that. So the work of Turkey 1977 is very crucial for us to understand why exploratory data analysis is very important. In fact, you find that what we call today machine learning, the platform was created by the proponents of exploratory data analysis. And you also agree with me that machine learning is becoming more pronounced in analysis of quantitative data because it has a lot of value as far as analysis is concerned. So in a nutshell, what I'm trying to propagate is the point that you can be able to use exploratory data analysis methods. Some of them are graphical, others are not graphical. Some of them are univariate, others are not univariate. You can apply them to find out interesting patterns. You can use exploratory data analysis to diligently come up with the hypothesis or generate the hypothesis that will pursue later using hypothesis testing statistics. At that point, my viewers, we come to the end of our seminal or preliminary discussion of research methodology. In our subsequent classes, we shall also look at some of the pertinent issues that influence students negatively when they are trying to analyze their data. For now, goodbye. This is your research methodology coach, Bidhi Mutua.